Welcome to the University of Washington, Tacoma, and to this first session on the informed discussions sponsored by Urban Waters and Citizens for Healthy Bay. My name is Joel Baker. I'm a professor of environmental science here at the University of Washington. I'm also the science director for the Center for Urban Waters, and I thank all of you for taking time out of what I know are busy days to trudge through what I know is a wet weather to come be with us this evening. I'm going to give a little bit of introduction to the overall theory and idea behind this discussion series and walk you through a little bit about what our thinking was putting this together and what we hope to accomplish, and then we'll get into the meat of the discussion tonight. So why are we here? We're here for, I think, pretty obvious reasons, I think, to all of you. There's a proposal that's been put in front of this community to build a natural gas to methanol production plant in the tide flats on 125 acres of Port of Tacoma property. That is the University of Washington, Tacoma, and my colleagues, Citizens for Healthy Bay and others, about a couple of months ago began to hear a lot of questions coming to us about this project, some of the detailed questions we didn't frankly have answers to. And as an environmental chemist who spent nearly 30 years studying water quality issues around the United States, I was a little, frankly, embarrassed. I didn't understand much about methanol. So some of the questions like, what is methanol? I know what methanol was, but why are you making so much? What is it used for? Those kinds of very basic questions. So we thought this series would really be designed to help the community establish a common understanding of the underlying science and engineering of the proposed project, and as importantly, to develop some context for developing each and every one of you your own opinion about whether this is good or bad for Tacoma. As I think everyone knows, we're doing this somewhat complicated time in the sense that they are just beginning the permitting process, and I think many of you are probably engaged in that as well. I want to be abundantly clear, this event and the events we're hosting is not part of the SEPA planning process. It's completely independent from that process. They have their role and their mission, and we have a different role and a different mission here. But part of that SEPA process is to engage in questions, concerns of the community, and I see these sessions as an opportunity to help all of you and all of us to craft better questions, more precise, more probing questions of the proposal, so that all of us in Tacoma feel like we really understand what's being proposed, and we can make our own evaluations. And frankly, my broad goal in this is to just continue work towards making Tacoma a community where not only where we preserve our community well-being, but we're innovative and we embrace new ideas as they come down. We embrace them because and when we understand them fully. So that's the broad objective for tonight. The strategy behind the series is really to take advantage of the University of Washington being in town. This is meant to be a venue for conveying the best available knowledge about methanol, about the risks of methanol, about the economic advantages and disadvantages of methanol, the why question. These sessions are built around questions that have come to us through Citizens for Healthy Bay and other venues, but CHB has done a great job of compiling questions from the community through a whole bunch of things I don't use: Facebook, Twitter, Pinterest. I'm just making stuff up now. Social media, lots of questions have come in. We solicited questions from all of you who have registered as well. So the design of the sessions is explicitly tied to the questions that we're getting from the community. I want to be clear that the speakers that we've chosen are those who have technical knowledge that we think is appropriate to answer the questions that are being addressed. They weren't invited here as representatives of their own organizations, and they're definitely not here to advocate one position, any of a number of positions. So they're here as individuals and as experts. Now, obviously, you know who they are and you know who they work for, so it's a little difficult to untangle some of that sometimes. But I ask, for the purposes of the discussion, to take everyone at their best intent. And as I mentioned, this is meant to complement and definitely not to duplicate anything that the city is doing through the SEPA process. So as I mentioned, we've actively engaged the community through to get the best questions. It is not too late to ask questions. We actively encourage this through whatever means possible. If you're an old guy like me, there's 3x5 cards. You can write a piece of paper and a pencil and hand it in. If you tweet or text or Facebook or any of that stuff, you can do that as well. All those questions are coming in, and later on this evening, Melissa Malott from CHB will get through as many as we can in the question and answer session, and many of the questions will be addressed in a subsequent few weeks. So just to be a little bit more exact about what we're doing tonight, my goal is to lay the foundation for this proposed project, and just to get everyone on a common understanding of why did this come up, why is it in Tacoma now, where did that all come from. We then arranged a series of talks over the next several weeks addressing the major questions, and not a surprise to you, the major questions are about use of natural resources, water, power, and natural gas. So on February 25th, we'll do a deep dive into those questions. On March 3rd, we'll address the possible environmental impacts of something like a methanol plant in a place like Tacoma. And then on March 10th, we're arranging some more of a roundtable discussion of members from the community who have engaged in the first 3 sessions to reflect on what they've heard and what are the key emerging issues that have come out of this. So that's the game plan. Let me just be clear about the ground rules. We are soliciting questions from everyone. We have been soliciting questions from all of you. I think there's ample opportunities to do that. We will address questions at the end. We're not taking questions from the audience because this is being videotaped, and we wanted to have those who can't come have a chance to ask the questions as well. I think we're all here for the same reason, and we just ask that everyone be respectful of others and allow the evening to proceed in a productive way. So this evening's session is really, as I said, the main goal is to develop a common understanding of what is being proposed and why, without making judgments one way or another. Just what is this thing that is being proposed? And I'll say at the outset that there's some uncertainty about that because I think, as most of you know, the fine details of this proposal have not been announced, and that's the way this thing works in the SEPA process. SEPA process starts when the idea, I mean, there's a fairly concrete idea, but the actual detailed answers to a bunch of questions have not been addressed yet. We are not privy to that information, and we're not doing that. What we're doing is our own independent research to develop our best possible answers to your questions. And our goal for tonight is to send you home with more questions than you came with. But we hope those questions are much better, much more refined, much more focused questions, and that you feed those to us to come back and for the subsequent sessions. So our lineup for tonight, I'll do introductions in a minute. We have 2 30-minute presentations for you, and then we'll take a very, very short break, and then we'll open it up and we'll do our panel discussion with the submitted questions. So that's all I have for introductions. I'd like to move on now to introduce Jason Jordon from Port of Tacoma. Jason is the Environmental Program Director, or was the Environmental Program Director since February of 2011. 2014, he became Director of Planning and Environmental Services, and more recently has been involved in both the Tacoma and with the new alliance between Seattle and Tacoma, has been very active in the environmental issues common to those, to the alliance. Before joining the port, Jason worked for the Port of Seattle. He worked for the City of Renton, worked for the City of Bainbridge Island. He holds degrees in economics from Western Washington University and has a master's degree in public administration from Washington State University, 2 of the top 3 universities in the state of Washington. So, Jason. You want this or that?
I'll use that. Well, Joel, I was going to say thanks for that great introduction, but I think I'll hold that. But seriously, thank you to UW-T for hosting this tonight. Thank you to Urban Waters for setting this up. And thank you to all in the audience for being here and sharing your Wednesday evening with us tonight. This is an important topic, and I'm really pleased to be here to talk about it. Also with me tonight is Tony Warfield. He's a senior manager in our environmental programs group, and he will be here after I'm done talking about the environmental review process that we plan to go through or that associated with the project. So just a little bit about ports, real quick. I promise not to labor too much on this. Ports were enacted by the state legislature way back in 1911. In 1918, Pierce County citizens voted in the Port of Tacoma. And ports are special purpose districts. So a good example of a special purpose district is something like a school district, just to give you an idea of what that is. But ports are very specific. It's outlined in RCW Revised Code of Washington, Title 53. It's really an economic development driver. Its mission is around economic development. We're also known as a municipal corporation. So a little bit of history of the tide flats around zoning and comprehensive planning. As you can see from this photo, I've outlined here in yellow the former Kaiser aluminum property and what we refer to as the EB1 wharf that would be utilized by the proposed methanol facility. But what I really want to talk about is the comprehensive planning designation for this area and the zoning. So this is in the cities of Tacoma's comprehensive plan. Its designation is heavy industrial, and it's also in a MIC, which is a manufacturing industrial center. And specifically, the zoning is port maritime industrial. So that's very specific, and you can see that in the purple. All that purple represents the Port Maritime Industrial, also known as PMI. What's unique about Tacoma is that their zoning code also includes a different subset zoning for the shoreline designation, and the shoreline designation is defined as the first 200 feet from ordinary high water. So that's why we've labeled the S10 there. S10 is the shoreline designation, and that is also related to port maritime related commercial and industrial activity. So talk real quickly about our strategic plan. Back in 2012, we went out to the community and asked them a little bit about the things that the port could be doing, and we came up with a 2012 to 22. It was a 10-year lookout strategic plan. I won't read all this for you, but you can see what our mission is around economic development. We identified 6 goals in that strategic plan. The first one being enhancing the port's competitive position. That was specifically around containers. You are all familiar with the 2008 financial crisis. The port had a lot of container business, so we went out and made an effort to look for other types of commercial businesses associated with that. So that's really what goal 1 is focused around. But skipping down to goal 5, that's the one I'm most proud of and that I've worked on a lot, and that's advancing our environmental stewardship. Specifically within that advancing environmental stewardship goal, we've identified several objectives, and I'm not going to read them all, but I wanted to focus on a couple. The first objective being to address environmental issues in advance of plan development, specifically taking on cleanup properties, contaminated properties to support the business opportunities, which goes hand in hand with the proposed methanol facility, and I'll talk a little bit about the cleanup work that the port has done at that facility. And then developing maritime-related industrial stormwater best management practices, and then ways to improve operational efficiency. So this just gives you an idea, a little bit of a flavor in terms of some of the things that the port has been working on since the development of our strategic plan. Real quickly, this is a graphic that represents some of the habitat mitigation sites that the port has developed over its history. The green-colored ones are existing habitat sites. The yellow-colored ones are potential habitat sites. This one, if you've gone out off a river road, you'll see it's under construction. We're really proud of it. It's our newest habitat site. Anyway, to give you an idea of the flavor of the great environmental work that the port has done in terms of developing habitat mitigation. And our habitat mitigation is really focused on salmon recovery efforts. A little bit about the work in terms of cleanup work associated with the port. This graphic is a very busy graphic. We don't own the port doesn't own all the property in the tide flats, but it owns about roughly 50% of that. And you can see that the ones that are identified in some form of color are in some state of cleanup, whether it's a complete cleanup has been conducted and we're in long-term monitoring, or we're in the investigation phase. And just to call out here, parcel 77 is the Kaiser property, and it's identified in cleanup construction, which is essentially that we're in the process. We just recently finished the last bit of physical construction associated with removing the contamination at that property, and I'll talk some more about that in a sec. So why do ports do remediation? This one's, I've thought a lot about. Ports, in my opinion, are uniquely situated to do remediation, to go in and take fallow property that's not being put into productive use, leverage port assets, leverage other financial assets, and then partner to find business drivers that fit the goals of cleaning up those properties. Quite frankly put, ports go in where the private sector won't, because it typically won't pencil out to clean up these historical contaminated properties. And then we do that work, and then obviously with the goal of putting that property back into productive use. I want to highlight that the port has invested, the port and its partners have invested over $175 million cleaning up Commencement Bay, which is represented on that previous graphic, in terms of the work that they've done, whether it's actually cleaning up sediments in Commencement Bay or immediately adjacent properties next to the shoreline. So out of that goal, you'll see here, we have, through our strategic plan, identified that we wanted to clean up 200 acres in 10 years. So on the axis over here is the acreages, and then down here is the years or time. And you can see it's 2016, we're well on our way to cleaning up those 200 acres, and we expect by 2022 to go well beyond the goal of 200 acres. Call out specifically here, this is obviously the big one. This was Kaiser and the work associated with the cleanup at Kaiser. Now getting specifically into the plant here. So this is from 1942, so this is right in the thick of World War II, so Kaiser's geared up for production purposes to support World War II. And this is just to give you a sense of what that facility looked like at that time. You can see that it was a bustling industrial setting in what now is the Tide Flats. The history associated with the purchase from the port purchased that property in 2003. The site had 70 buildings on it, 25 other features. That features could be a smokestack or boilers, equipment, a lot of infrastructure in the ground, as you can imagine, and of course that 500-foot smokestack, which a lot of folks reference. So this is a great example, a photo. I couldn't perfectly identify the time associated with this photo, but I believe it's from the late 60s, early 70s, and I want to call it a couple important facts associated with that. So obviously Kaiser was an aluminum smelter. They took alumina ore and broke it down and created aluminum out of it. This was the first phase of the plant, so if you go back to that first photo I showed you, this was what was in operation from the beginning. And then the second phase of the facility, you can see the differences just in pollution controls from the late 60s and early 70s. You can see the soot and lack of pollution controls associated with that versus the new facility. These were the technology required that the emissions associated with this manufacturing process go through a wet scrubber sludging pond system, which took out a lot of the PAHs, which are known to be carcinogenic, and put those into the settling ponds associated with that. So you can just see from this operation there was a lot of industrial activity, and there was a significant cleanup associated with that. The other thing I'd like to call out is the power substation here. Obviously, this took a tremendous amount of power to generate this particular industrial use, and that you can see that even back in the 70s. And then the last thing I'll mention about this is that there were 3 deep artesian wells that Kaiser used as part of its production process. And so they had access directly from the property for these deep artesian wells to help with their manufacturing process. When the port went through and cleaned up this property, we decommissioned those wells and then sold the water rights back to Tacoma Public Utilities for a very nominal amount. And so those wells aren't being currently used, but now Tacoma Public Utilities has the water rights associated with those. So a little bit about the cleanup specifically. Like I mentioned, this was a smelter. We purchased it in 2003. It was governed under the RCRA, which is Resource Conservation and Recovery Act, and that's really associated with handling hazardous materials. And the reason why it was hazardous materials was from some of the byproducts associated with the manufacturing process, specifically the PHs, which are known to be carcinogenic. The port completed substantial demolition and cleanup and has graded the work site. And currently, all the remedial actions under RCRA are resolved and also under M.P.A. And M.P.A. is the Model Toxics Control Act. So it was part of the site was governed under RCRA, which is more rigorous. It's a federal regulated, mandated program, and then M.P.A. is under the state program. So the port, as part of the demolition and cleanup, recycled over 60 million pounds of material from that. And we were really proud of that because that wasn't the cheapest alternative in all cases. In some cases it was because we could get the recovery fee for some of the metals, but we worked really hard with our executives and our commission to make sure that we could finance and plan to recycle as much material as possible. So we're really proud of that. And then, of course, we disposed a lot of industrial, industrial waste there. You can see 35 million pounds of waste. So this gives you a little idea in terms of what the port has spent cleaning up this property. And Joel alluded to, I'm an economist. We actually, ironically, have two other economists in the environmental department, so we like these kind of charts. But you can see the land purchase, and then the reason why it fluctuates, this line fluctuates, is because we did receive some grant funding from the state and actually a little bit from the feds to help clean up that property. But what I want to point out here is that including the land purchase, the port has invested over $35 million purchasing and cleaning up that property, which is significant. So here's what it looks like today. Much different than those photos that I showed you from before. So it's essentially all the structures are removed. All the remediation to remove the contamination from the property has been removed. There is still some contamination left in the ground that will require long-term monitoring. We are at a stage where we have completed the remedial cleanup action plan, and now we are negotiating a final consent decree, which will provide the specifics around material handling on site and also long-term monitoring. We expect that there will be some long-term monitoring in perpetuity. There'll be a covenant on the property that outlines the work that has been done and the contamination left in place. And there'll be a requirement on the port to have a financial assurance associated with being able to perform any of that future work. And so I want to be real clear about that. When we enter into this final consent decree, we will have to demonstrate to the state and federal agencies that the port has the resources to do the required work in terms of monitoring or any other work that would be required as part of the final agreement. And that is on the port in our plan of finance. So a little bit more about the land. So the site is 90 acres in size. We talked about the zoning, maritime industrial. Here you can see in the lower right-hand corner the EB1, East Blair 1 wharf. It's a 16-acre wharf. It's a relatively new wharf. It was constructed in the 2005 to 7 timeframe, I believe. It's 1,200 foot long, and then the water depth in the Blair Waterway is 51 foot. Another angle of the relatively new-speaking wharf in terms of what it looks like today. And then, of course, you can see the Kaiser backland behind it. And this is another great shot of that wharf. And then, of course, and Kaiser off in the distance. So moving into the lease, the Port Commission on May 1st, 2014 approved a 30-year term lease with a potential for a 25-year extension. But I want to be really clear that the lease was set up specifically to go through some very designated phases. So the first phase was an 18-month feasibility study period, which was really in order for the commission, for the applicant to go through the process of figuring out any design-related requirements, any permitting-related requirements, really to do their due diligence and feasibility in terms of what it would take to build the proposed methanol facility. I know that says 24 months because the lease had a 6-month extension built into it where the tenant could ask for that 6-month extension, and they have done that. So that will take us through May of this year. Beyond that, it goes into a construction period that the tenant expects to take a minimum of 3 years, could be longer, and then from there it goes into an operational period, and that operational period would take it to the termination of the lease. So with that, I think I'm going to turn it over to Tony, and he's going to walk you through the process, the environmental review permitting process associated with the project.
All right, good evening. Thanks again for coming and taking time out of your Thursday evening to join us here. I've been asked to walk through a mind-numbingly complex process that takes about 2 years and 15 minutes. So my apologies if maybe I don't go into the depth you'd like to know. You can always catch me at break or afterwards, and I'd be more than happy to dive in deeper and give you more detail than I might have here. So any big project, any project in this state starts with the environmental review process. There's really 2 chunks of this. There's environmental review and there's permitting. And the thing about environmental review, it's done in the state under the State Environmental Policy Act. It's a bill or a law we've had in place since the early 70s. The federal government has an analogous piece of legislation that came a year before this one. And the point to SEPA is to look at the entire project. You know, permits look at little slivers of things like water or air or whatever. SEPA is meant to look at the whole project, take a holistic view of the significant adverse impacts of a project. To distill down the SEPA process for this evening's purposes, there's really kind of 4 elements I think we should be focused on. Right now, what's going on, well, the first thing you do in SEPA, if you have a project that's big enough to warrant a full environmental impact statement, which is actually fairly rare, there's only probably a dozen or so a year statewide, that the first thing you have to do is scope the project. You have to understand, what are you studying? You can't just study. You need to understand exactly what you need to look at. So there's a scoping period, which is what we're in the middle of right now with this plant or this project. And it started in a formal sense on December 15th when the city issued the scoping notice. As you know, we all know there was a public meeting 3rd week of January. There's one last night. There'll be another next week. And these meetings are meant to take public comment on what the city should include in the scope of study for this environmental impact statement. You know, at this point, it's not really meant to be, we love it, we hate it, we love it, we hate it. It's, what should we study? The point is, you don't want to miss anything when you're doing this study. They're long, they're expensive. You want to get it right the first time. So the public comment period will close March 4th. The city will wrap that up. All comments, they go to the city. They have a website set up for this to receive the comments, or obviously you can do them in person at a meeting. From there, so now that when the city has, or in any EIS process, when you have your scope defined, then you need to develop the studies that go into developing an environmental impact statement. And it depends on the project. You know, there's some projects you might have a whole lot of wetland studies because you're impacting wetlands. Or, you know, this project will have a different set of things that need to be studied. So these technical reports are developed. It's usually anywhere 6, 8, 10, 12, depends on the project. They will do things like focus on air emissions, air quality. So you'll take a look at the air emissions from any proposed project. You might do dispersion modeling. You might look at receptor points. There's all kinds of really highly technical stuff that goes into it. And these studies that come out tend not to be very digestible to the general public, or even experts who are an expert in a different field. So then to do this right, you need to distill them into a very clear draft environmental impact statement. Okay, so a draft environmental impact statement, if it's done right and well, is actually concise. Back in the 70s, they could take up entire bookshelves. Really, to make them useful, they need to be reasonably concise, They need all the, relevant information, but they have to be concise and they have to be clear. And that's actually the hard part in producing these documents, is making them so everyone in this room could read it, understand it, get it, know what's going on with the project. So that's the big challenge. They're developed by, the city will hire an independent consultant who has expertise in this field to assemble the document. The city's looking to have that document done. I keep saying the city because the city of Tacoma is the SEPA lead agency. Depends on the project. It could be, if you're in King County, it could be the county, it could be WashDOT if it's a bridge, or whatever. So the city is the SEPA lead agent for this project. They are striving to have the document prepared by late September, which, considering the complexity, would be a fantastic timeline. I hope they can get there. But then when this document is issued, SEPA defines how long the public comment period. There is a public comment period. The minimum's 30 days. You can go to 45 days. The project of this size, you'd expect the longer of the time frames. And so there'll be a public comment period, and this is when we actually know stuff. I mean, this is when there's real data to look at. We know what the air emissions will be. We'll know what the impacts of liquefaction could be on the project. Well, we'll know those kinds of things at that point because the studies will have been conducted. As part of those studies, so what you're doing is you're studying potential adverse impacts. And for those impacts, you're looking for mitigation measures. And mitigation can take a lot of different forms. It could be investments in public infrastructure, like you need to build a road, you need to build a firehouse, you need to do something. It could be investment, you could be providing, it could be operational and design changes. That is common in these kinds of processes where you look at it and you go, well, if you change process A little bit, you're going to significantly reduce your impacts. So these studies will look for those adverse impacts, they'll look for potential mitigation measures, and all that will come out in a draft document. So then the public, which will mean the general public, affected tribes, agencies, other governmental, businesses, anybody, will have the opportunity to digest this big document, to comment on this document. Those comments will go into the city, and what they'll do is they'll take a look at them and they'll try to categorize them into like comments, because maybe there'll be 8, 10, 12, 20, 50, 100 categories, whatever it ends up being, but they'll try to make sense of each, of these comments. And then they will take this to the applicant and the consultant that prepared the document and say, all right, guys, address these comments. So that it will be incumbent on those entities to then go through comment by comment and address it throughout the document. That might mean some changes to the document. That might mean responding to the comment in a different way, whatever's appropriate, but there will be a response for each comment. And then after that is completed, you issue a final environmental impact statement. The city is shooting for January of 2017. Again, that would be great on that, if they can make that time frame. It's a complex project, we hope, they'll get there. And that will define final mitigation measures. That document will say, here's what we studied, here's what we heard, here's the final measures. Now, that's only part of the process. So when you have this document, the way the law works in Washington State, no state agency or local agency can issue a permit until SEPA is complete. So they have to get this final environmental impact statement in place before the permit can be issued. And I'm talking about big projects. Smaller projects have a slightly different path. So I'm going to start with federal permits. I'm going to go as quick as I can, but there's a lot of them. So the Clean Water Act from the early 70s is implemented by the U.S. Army Corps of Engineers, Department of the Army permit, it's called formally. Anybody who's going to dredge or discharge in a water of the U.S. Has to have one of these permits. So if you're removing, if they had to deepen the wharf, if they had to, make changes like that, they need a Department of the Army permit. The next one down is a permitting process also managed by the Corps of Engineers, but it's done in parallel with the first process there, the Clean Water Act 404. The Rivers and Harbors Act, Section 10, is actually considered one of the first environmental pieces of legislation ever instituted in the U.S. It comes from the late 1890s, I believe. And if you're going to do something if you're going to discharge anything into a river, a navigable river, or a waterway, you need a permit. If you're going to build a structure in that, you need a permit. So this section, again, coordinated by the Corps of Engineers, but that's where the U.S. Coast Guard really comes into the process. They can come in other ways, but that's the way that they formally get brought in. Again, under the Clean Water Act, you have something called Section 401, Water Quality Certifications. That is actually implemented by the Department of Ecology. It's yet another part of the Clean Water Act, and what ecology has to do is look at a proposal and say, this proposal will or will not meet state water quality standards. The Department of Army cannot issue a 404 permit until the 401 certification is complete. Where are we? Coastal Zone Management Act Consistency Certification. It's another, it's an ecology certification saying that that any given proposal is consistent with the Coastal Zone Management Act. All right, various approvals under, so this is kind of honing in on the project itself. As Jason noted, there will be lots of work within the Model Toxics Control Act to make sure that, there'll be the cleanup action plan, there'll be soil management plans, institutional controls, these things that anybody doing work on that site has to do and has to coordinate with ecology on. You'll see the asterisks by several of these. Those are permits or processes for which there's a public comment period. If it doesn't have an asterisk, at this point, there isn't a comment period. Let's see. So then, moving on down, anytime you disturb more than an acre of soil in Western Washington, you need a stormwater construction permit. And there's a general permit that, if your property is reasonably clean, you can use. It's a fairly straightforward process. If your property is contaminated, it's under a MACA order, any of that sort of thing, then there's a whole different process. It's far more complex, and you get an agreed order rather than a general permit. I'm not going to... Air quality. Okay, so air quality is also really complex. Yes, this is mind-numbing. I apologize, but if you really want to understand permitting, this is what you go through. Anytime there's a new air source in the state of Washington, you have to file a notice of construction, or at least in the Puget Sound Clean Air Agency's jurisdiction. It's called a notice of construction. And in that notice of construction, you describe your emissions, your control technologies, your equipment, all that. You need to meet best available control technology. So they don't allow you to put in old stuff. You got to put in the newest, best stuff to control your emissions. If you are a minor news source, it's a pretty straightforward process. You go through news source review. It's often a couple of months process, and it works pretty slick. If you exceed a certain emissions threshold, you're called a major source, and then you go into a process called the prevention of significant deterioration. That's when you get into dispersion modeling and point analyses and all kinds of very sophisticated analysis. And that process actually takes a couple years. And I believe it is still administered by the Department of Ecology. And it's not that part, it's not been delegated to local air authorities. Okay, the top two bullets here, all the permits I've talked about so far are to get to construction. These next two bullets here are about operating a facility. So if you have a major air source, you need something called a air quality or a Title V operating permit. And it basically provides parameters, reporting requirements, and that sort of thing about how you operate your facility. And it's not clear whether or not this facility would have high enough air emissions to trigger that threshold. There's also the Emergency Planning and Community Right to Know Act that applies to a very wide range of businesses. A paint shop, for example, an auto body paint shop. This law might apply to it if they have it depends on what the quantity of hazardous chemicals you have on site is. And really, there's lots of things this law does, but when you get right down to the core of it, it's the protection, so the community knows what's in any facility that has chemicals above a certain quantity or threshold. But it's really protection of first responders, so that firefighters know when they're going into a facility what's there. You just don't want to you don't want someone charging into a fire with water when you're dealing with a chemical that reacts with water. So, they need to know those things to go in with foam on those kinds of situations. Let's see. So, third bullet down, now we're getting into what the city controls. So, everything up, from the third bullet down up is either a state or a federal or a state permit. And now these ones where the city has control. Shoreline substantial development permit, anytime you develop anything within 200 feet of a defined shoreline, you need to go through a permitting process. And that development needs to be consistent with the local government's shoreline master program. And then you get into critical areas preservation permitting. That is, critical areas could be wetlands, they could be the shoreline buffer, they could be very steep slopes, floodplain areas. There's lots of things that count as a critical area, and the city of Tacoma has a permitting process for that as well. Shoreline and critical areas are usually done in tandem. So it's essentially one permit does both processes. Okay, process water discharge permit. It's nothing I'm an expert on, but the city of Tacoma has a pretty rigorous system in place where if you're going to discharge processed water to the city's sanitary system, you have certain pre-treatment. You can't just discharge really nasty stuff. You have to treat it to a certain point on site, and it is measured and monitored over time before you can use the city's sanitary system. And then building and operational permits, there's a whole slew of things. If you think about building a house, everything you'd have to do, you'd need a mechanical permit, potentially. You would need electrical, all kinds of, structural permits, all that kind of stuff. So that would apply to this project, but in spades, on steroids, really. It would be, so, fire will have a review for this, clearing and grading, stormwater potentially, there's all those things that have to be reviewed within that permitting process. And that's it from the ports.
Thank you. Okay, let's take a big step back and talk about methanol, about what it is, why it's made, what it's used for, things of that nature. And I wanted to begin by doing a couple of things. One, I want to thank Haley Matthews. Is Haley here? Stand up, Haley. She likes to be embarrassed. Haley is one of many fantastic University of Washington Tacoma undergraduate students. She's done a lot of the research you're about to see over the last month or so. Got into the literature, got into some calculations, learned a lot of chemical engineering calculations. So thanks to Haley for that. I also wanted to say that this presentation is not based on information provided to us from Northwest Innovation Works, is based on our study of the literature and our study of very similar types of plants around the world. So 3 questions for the next 30 minutes. They use the microphone. John Burkhardt, everyone. Thank you. Use the microphone. So 3 questions, why methanol, why now, and why Tacoma? The analysis that you're about to see was really guided by 3 pretty simple principles. First principle is everything ends up somewhere. So if you're bringing something onto a site through a pipeline, through a truck, through whatever, if it comes onto your site, it has to end up somewhere. It has to go somewhere. So there's this concept of mass balance. Related to that is you can't make something out of nothing. There has to be some process, plausible process, to create something that might be a problem. And the third guiding principle is Scotty is right. Anyone? Anyone? You can't change the laws of physics. Okay. So a lot of our calculations are simple things like, heat flows from hot things to cold things. Water flows downhill. Pretty simple stuff that we did. All right, so really basic, what is methanol? It's a clear liquid at room temperature, right? It's a good solvent, very good solvent, in fact. It's also known as methyl alcohol. It's known as wood alcohol because it used to be made from wood. It was very early days. People made, probably one of the first solvents you could make at home is you can make wood alcohol. You can make methanol at home. Wood naphtha, methyl hydrate, comes from a bunch of different names. It's basically a pretty simple molecule. It is, chemistry. Who took chemistry? So it's a carbon, 3 hydrogens, and a hydroxyl group there on the end, which makes it the alcohol. Is methanol toxic? Yes, absolutely. Methanol is toxic, like most chemicals. This one is particularly toxic if you swallow it. Your liver will convert it into formic acid fairly quickly. And formic acid is a pretty severe metabolic toxin. And among other things, it causes blindness. This was a big issue during Prohibition. People didn't get their moonshine quite right. End up with methanol in their moonshine and would go blind. Here's a tragic but somewhat interesting thing I pulled out of the British Journal of Ophthalmology. Acute bilateral blindness, that is, went blind in both eyes, caused by accidental methanol intoxication during fire eating. So if any of you are doing the fire swallowing thing, getting burned is only one of your problems. If you swallow the if you're using methanol as the flammable solvent, you better be careful. All right. Does methanol burn? Yes, absolutely. Methanol burns. Once ignited, it burns with a nearly invisible flame, which is one of the safety issues with it. Nearly invisible also kind of translates into a fairly low temperature flame, but yes, methanol, you can light it on fire. It's not as flammable as some other things that you know about. And let me show you, let me go back to this graph here. This is something called a flashpoint apparatus. Really simple idea. You take your liquid, methanol, gasoline, water, whatever you're interested in, you put it in this container, you measure the temperature of it, you hold a flame over it, and if it catches on fire, you've exceeded the flash point of that material. So you usually start with the stuff really cold. It doesn't catch on fire. You put the match on it, you keep doing it, you heat it up, and eventually you put the match on it, and it goes poof. So I get to spend the summer doing this as an undergraduate chemistry major one time. So it's actually a hell of a lot of fun. So the flash point, the higher the flash point, the hotter the fluid has to be to catch on fire when exposed to a flame. So the flash point of methanol is 54 degrees Fahrenheit, roughly the ambient temperature around here most of the year. Gasoline has a flash point of minus 43 degrees Fahrenheit. So no matter how cold gasoline is, if it's exposed to a flame, it will catch on fire. Methanol will not catch on fire unless it's above 54 degrees. The other numbers, the lower flammability limit is how much methanol or gasoline you have to have in the vapor phase in order for it to catch on fire. So if you don't have, if you have less than 6% methanol in your air, it won't catch on fire. It's too lean of a mixture. 1.4 for gasoline. The other comparison is this heat of combustion. That's how much energy there is in methanol. Don't worry about the units, kilojoules per gram for those of you who are in the know, but the point is there's half as much energy in methanol as there is in gasoline per volume, per mass in this case. So yes, it burns, not quite as flammable as gasoline, and it contains half the energy content of gasoline, just to kind of scale things. Okay, what do we use methanol for? 20,000 tons of methanol a day. What are you going to do with 20,000 tons of methanol a day? Well, it's used in Indianapolis 500 race cars. Right? So we could just have a lot of Indianapolis 500 races. It's used as a fuel in these race cars, but you can get a very high compression. It's super good energy for race cars. You can set an engine up really well. The downside is the gas mileage in these things is horrible. Right? They don't seem to care that much. And you may remember, or may not, years ago, there was a push in California to switch the fuel fleet to methanol. Right? We're on gasoline. Big push to go to methanol. This is before the days of Priuses and electric cars and things like that, for air quality reasons. Right? Big smog issues in Southern California. One of the solutions was to develop a fleet of methanol-burning cars, develop a distribution network of liquid methanol. So a big push for that. Turns out it kind of fizzled out for geopolitical reasons related to the ethanol and corn, but we can talk about in a completely different talk. But there's no way you're going to burn 20,000 tons of methanol a day in Indianapolis race cars. Or other as a vehicle fuel. The big use of methanol is what's called a chemical feedstock. That is, it is converted. It's the first step in a often long series of chemical reactions that result in things that we buy or use. So methanol is used to make plastic. I think most people in the room probably have heard that or understand that. So on the left is a plastic bottle. But it's also used to make a lot of other things like adhesives. So plywood, which is shown here, those aren't Necco wafers, those are plywood. The urethane adhesive in plywood, about 30% of the methanol in the world that is produced is converted into formaldehyde. Formaldehyde is the starting point for the adhesives and things that go into making manufactured products such as plywood. So it turns out the price of methanol scales to the global building trades market. The other interesting thing that methanol is used for is making carbon fibers. I've had a few people tell me, well, we're not going to use plastic anymore. We're going all the way to carbon fiber. Well, carbon fiber is made of carbon. The carbon in carbon fiber comes from either methanol or some other similar small molecule feedstock. Okay. So here's a Boeing 787. And as you know, the production is, the state of Washington gave Boeing a bunch of money to make that wing in Washington State. It's made out of carbon fibers. The carbon fibers ultimately go back to either methanol or something similar to that. So it's more than plastic and plastic bags. More examples of the kinds of stuff that you can make with methanol. That's the reason so much of it is produced. But here's the big change. Within the last decade, there has been a rapid increase in this stuff called methanol to olefins, or the MTO process. And this is a paper written by a series of scientists and engineers from the Dalian National Laboratory for Clean Energy in Dalian, China, where they describe in great detail how you can take methanol and turn it into an olefin. Now, why would you want to create an olefin? What is an olefin? Those of you who remember organic chemistry, olefins is just a different name for an alkene. If that doesn't help you, let me give you more examples. So ethylene and propylene are two olefins, right? And from ethylene, you can make polyethylene. Hopefully you all know polyethylene. You see that kind of plastic. I suspect without getting out of your chair, you could touch a piece of polyethylene in this room. From propylene, you make polypropylene. So methanol converted to these olefins is the starting point to make all kinds of these polymeric chemicals. That's what's driving the demand. Another form of olefin is butadiene, which is used to make synthetic rubber, which is used to make tires. So when you look at your car, when you look at the tires, that came from the production of methanol. So why is methanol used so much worldwide? The simple answer is it's a very versatile intermediate chemical. We can make it from a bunch of different things. We'll talk about that in just a second. And it can be used to make a wide variety of products. So I was searching for an analogy, and this may not work, so don't boo too much. But in some ways, methanol is to chemical manufacturing as flour is to the baking industry. Right? Nobody eats flour. You eat flour raw. Right? You can make flour from a bunch of different things. You have wheat flour, rice flour, all that kind of stuff. And you can make a bunch of different products from the flour. Methanol is basically the same deal. It's that very useful intermediate. And the demand for this stuff is going off the charts. This is a plot of global demand in millions of metric tons of methanol from the year 2000 to the year 2025, obviously a projection. And you can see, without doubt, this line is going up. And the big blue blob on the top is the internal demand in China. So China is very much driving the demand, although the other parts of the world are also increasing in their demand. But the big chunk of this is increased consumer demand in China. So we're not the only ones to figure this out, this global demand thing. There are a number of plants around the United States that are currently either under construction, have recently become operational, or are proposed to produce methanol. So there's a real boom in methanol right now. I stole this out of an ADI analytics report. So you can kind of get a sense of the other plants that are out there. You can see the other Northwest innovation plants that are proposed. And just for scale, the proposed Tacoma plant is by far, so this is M.P.A. is millions of tons per year. where it would be at 7.3, and you can see it dwarfs the other ones quite a bit. So this is a big methanol plant, no doubt about it. This would be a big plant relative to the others. But there's a lot of players in this game. There's a lot of other parts of the getting into it. All right, so that's why anyone would want to make methanol in the first place. Without boring you with a chemistry lecture, I think the only thing worse than a permitting lecture is a chemistry lecture at this time of night. I can assure you. So I'll try to make this as painless as possible. How do you make methanol? So you start with a carbon source. More about that in a minute. Water, air, and some form of energy. And you have this stuff called catalyst, which you need but is not consumed in the process. And we'll say more about that later. You cooked all that together in a plant, and you form this stuff called syngas. Syn, not like biblical sin, but syn like synthetic gas. Okay? And all syngas is a mixture of carbon monoxide, carbon dioxide, hydrogen, and steam. Basically what we're doing is we're taking the carbon source, and we're thermally decomposing it. Right? We're heating it up, and it breaks apart into carbon monoxide, carbon dioxide, hydrogen, and steam. These are all gases. This is all done at a very high temperature and under pressure. You form this stuff called syngas. Syngas has no value to anyone. And it doesn't leave the plant. This is all internal to the plant. What you do then is you pass this syngas over a catalyst. And for the chemical engineers in the audience, I apologize. This is a gross oversimplification of what you do. But you get the idea. The syngas passes over a catalyst. Voila, out the other end comes methanol. Some combustion products, perhaps, depending on how you do it. Some wastewater, and lots of hot water. Okay. There's eventually this catalyst stuff, which is a solid, I'll say more about in a minute, wears out, and you have to replace it. And any impurities that get carried along the way, come in on any of the inputs, or produced within the plant would be outputs as well. Okay, I think I'm going to skip that. That's just to show you there's a nice drawing. I will say that this drawing came from an environmental report for a very, very small facility in Coogee, Australia, which uses exactly the same technology as proposed here. So there's a pilot scale plant in Australia that's been operational a few years, several years, much smaller than what's being proposed for Tacoma, but the technology is very, very, very similar. So the proof of concept is out there, and there's lots of good environmental data for that plant, and you'd have to scale it up to the size of this plant. So this is, these plants have been built and operated. Okay, so how do you make this stuff? You have two choices for the carbon source that are economically viable. You can either make it out of coal, or you can make it out of natural gas. What we'd really like to be able to do is not use either one of those, right? We'd really like to be able to make it out of biomass, that is, waste, biomass stuff, grass clippings, or capture carbon dioxide out of the atmosphere. I'll say more about that in a minute if I have time. Or you can get organisms to make methanol directly for you. You can get rid of this plant altogether and just have organisms, genetically engineer them or do something to them so that they make methanol directly. None of that stuff is ready for prime time. None of that stuff is going to hit this demand curve that we're seeing. Yeah. So the choice is coal or natural gas if you're going to do this. And this graph goes through some, and again, these are our calculations, so take them with a grain of salt, but I think they're reasonably good. If you want to make 1,000 gallons of methanol using coal, you need about 14 tons of coal to start with. You're going to release about 46 tons of carbon dioxide into the atmosphere. You're going to release 58 pounds of sulfur into the atmosphere as sulfur dioxide, and you're going to end up with about a ton of fly ash on the back end of it. And only about 20% of the coal gets converted to methanol. The rest of it gets burned off or ends up in the waste product. So it's a relatively inefficient process. If you use natural gas, you can read the numbers, use much less to start with. The cool thing about natural gas is it's almost pure methane. For a geologic product, I mean, something you're digging out of the ground, dig it out, but you get it out of the ground, it's as close to a pure compound as you're probably going to find in the environment. So about two tons of carbon to make 1,000 gallons of methanol. Not a lot of carbon dioxide is released inherently by the chemical process itself. There's probably carbon dioxide being released by burning whatever you're going to burn to heat up the steam and things. And I'll say more about that in a minute. So that's a big unknown. A little bit of sulfur in natural gas. About 0.6% of natural gas is hydrogen sulfide. So there's a little bit of sulfur, but not much, and you don't generate any ash. So the yield for converting natural gas to methanol approaches 100%, not including if you use any natural gas to heat the material. So the source of carbon really matters here. Really, really matters. All of these things are imperfect. Mountaintop mining, I grew up in southern Ohio. This is taking the top of a mountain in West Virginia to get the coal. Deepwater Horizon oil spill, a fracking natural gas well. So all of these have environmental impacts, something to think about when you think about the source of the material. Moving the stuff around the country has impacts and risks. I don't need to talk to this community about coal trains and oil trains, and natural gas would come in by pipeline. So we're going to hear a lot more about these issues in subsequent sessions. Sources of electricity are really important here as well. And so we're getting into the why Tacoma question. You have two choices. Choice number one is you're bringing something in, you're either coal or natural gas you're bringing into the system. So why not just burn some of it and make your own electricity, right? Build a little power plant on site, burn it through a turbine, and you make electricity. Many of the methanol plants in existence use about a third of the coal or natural gas comes in. They burn it to make the electricity to convert the other 2/3 into methanol. Okay. Or you can buy it off the grid. And then the environmental impact depends on where that power comes from off of the grid, right? So it all depends on the source of power. Water. Let's talk about water for a second. It turns out there's actually 2 water streams that are required to make methanol. The first one, which I think is about 20% of the total water demand in any methanol plant, and again, this is our assessment based on reading the literature. This isn't information from any specific project, but about 20% seems to be a pretty good number, is high purity processed water. This is the water that is used as steam, and this is the oxygen molecule, H2O. Remember I showed you methanol earlier and it had that oxygen? That's where that oxygen molecule comes from. Oxygen atom comes from. It comes from the water. Okay. So you need that. It's about 20% of the water demand. The rest of it is cooling water, what's called non-contact cooling water, using a heat exchanger, about 80% of the cooling water. So you're taking cooler water, you're using it to cool down the process at the back end, you're generating a bunch of hot water, and you have to deal with the hot water. So the impact of all this depends on where you're getting the water from and the extent to which you recycle the water. All right, so what might this plant look like? I think a lot of us are struggling with, we see the site, right? We see the map, and there's a big vacant lot there. If you build it, what would it look like? Let me take you through a couple of the key steps, and then we'll try to wrap up here as I'm running along. Let's just think of the steps, and these are the things that these are the kinds of questions I think we all should be asking about this. Okay, so step one is let's assume we're going to use natural gas. Right? Hopefully I've convinced you that coal is a really bad way of doing this. So let's assume we're going to use natural gas. It's going to be delivered by a pipeline, so you have all the issues about building a pipeline that we don't want to get into right now. First step is on site, you're going to compress the gas, and you're going to remove the sulfur. So things to think about, where did that gas come from? What's the environmental impact of wherever you got that gas from is an important question. A really important one, how much natural gas leaked out between wherever they put the hole in the ground and got the methane out and to get to Tacoma, how much methane gas leaked out, right? And the answer for that is somewhere between 0 and some unknown amount, right? And the reason that's really important is because methane is a very potent greenhouse gas. So part of the argument of using natural gas and electricity for making methanol is that you're reducing carbon dioxide emissions, which is absolutely true. But if you leak methane along the way, you're offsetting some of the benefit of it. Okay? So it's not as clear-cut as you might want it to be, but the great question, which we could ask our representatives from that part of the industry, is what's the estimate of how much gas is going to leak out as the material is delivered to us? How much power are we going to use to compress the gas? That's a pretty straightforward calculation. It's probably electricity to big compressor. And then what happens to the sulfur? Right? I mentioned there's a little bit of sulfur. Usually what you do is you'd pass it over a metal like zinc or something and generate a little bit of solid waste. So what happens to that stuff? All right, so the second thing you need to do is to inject pure oxygen into this system, right? So this is all hot, right? So now we got these super, fairly high temperatures, under pressure, gas moving through this plant. And you're going to bleed, not bleed, you're going to pump, you're going to release pure oxygen into this gas. Where'd the oxygen come from? And what about fugitive emissions? We're doing this stuff on a large scale. And does anyone think you can move that much material at those temperatures and not lose some of it along the way? I think this is a little bit optimistic. So there's the question about what are the fugitive emissions coming out of these plants. All right, so where the oxygen comes from, it turns out Tacoma already knows the answer to this question because we already have one of these. This is the Praxair, well, this is actually not ours, but Praxair in Fife, and you drive around the, just across from Port of Tacoma Road, is a facility that makes oxygen and nitrogen in a very simple process. You take air, which is free, it turns out, and you cool it down in a really, really, really cool freezer, for lack of a better term. So you take air, liquid air. If you lower the temperature to less than 320 degrees Fahrenheit, it turns into a liquid, and it turns out that the nitrogen will boil off. Which way are we going here? Yep. Did I do it backwards? I typed these backwards. So nitrogen has a lower boiling point. Yeah. So nitrogen comes off first, then the argon comes off, and then pure oxygen is left behind. Okay, so you're basically you're harvesting the oxygen out of the air. This requires a lot of electricity. Your home refrigerator, think about your home refrigerator, you're not going to minus 320 degrees Fahrenheit. Most of the electricity demand for this plant is going to be doing this. Okay. That's where that comes in. You also make a lot of nitrogen gas that you don't really need for the process. But nitrogen gas is a great way to reduce fire risk when you have flammable solvents, but you can put the nitrogen gas into the tanks and keep all the oxygen out as a side benefit. All right, here's the thing about the catalysts. The catalysts are solids. They look like that. They contain metals, copper, zinc, magnesium, and aluminum. They're designed, and in fact, they're super expensive. So there's a high motivation not to lose this stuff. So this is, like, think of it in the walls of the reactor, in the plant. It's hot. And this syngas is passing over these solids. The reaction that actually creates the methanol is happening on the surfaces of these things. Catalysts like this usually last several years. You sort of install a bed of this stuff, and it lasts for several years, and then you have to replace it. So a good question is, what are you going to do with that old stuff when you take it out? But there's really not a lot of evidence that the metals in this catalyst would be leaching into the gas. So that's a question somebody should ask. Probably already has. Okay. So now you have methanol, right? You have methanol, it's extremely hot, it's in the gas phase, but it's not really all that clean. It's called raw methanol. It contains water and any of the other impurities and side products and stuff. No one's going to buy your methanol. It's crummy methanol. You got to clean it up. The way you clean it up is by distillation. Methanol boils at 148 degrees Fahrenheit. Water boils at 212. So basically what you're doing is you're distilling the methanol. You're heating this raw methanol. Methanol goes off as a gas, and the water stays behind. If you're interested in water quality impacts from this activity, that's where the action is. That's the water you want to keep your eye on. Okay? What do you do with that water is really going to be important. Okay? The cooling water doesn't come in contact with any of this. Right? The cooling water is outside of the process stream. It's in jackets around. So it's extracting heat out of the system, but that water is not coming in contact with the catalyst. It's not coming in contact with the syngas and all that kind of stuff. Okay. The cleaning water probably doesn't need to be as clean as the process water. The process water is part of the chemistry, so it's got to be like H2O and nothing else in it. Cooling water can be, doesn't need to be as clean. And what do you do with the cooling water? Most of it, usually is evaporated, much like you have when you're making paper, and you see these big clouds of steam coming off of, actually condensed water coming off of a paper mill. Same kind of deal here. Water's much too hot to discharge into surface water. It would be evaporated back into the air as a way of cooling it down. And what remains behind is probably some water that's pretty salty, right? You're distilling off the water, and you're going to concentrate the salts in the water. So that's the cooling water versus the process water stuff. So what about the air emissions? Sure. What's the possible list? If you burn the natural gas to make the steam, right, early on, or you burn natural gas to make electricity, then there's going to be emissions from burning the natural gas, just like there is in any other natural gas-fired boiler system. All along the way, this is gases at high temperature and high pressure, so you have to worry about venting or pressure relief during startup, routine operations, maintenance, upsets, and things like that. So there's always this, okay, so what happens if something happens and you have to divert the gas out into the air? What's that going to look like? Volatilization of chemicals from the cooling water is certainly possible. That's always a concern to think about. And then, 20,000 tons of methanol a day, it's a volatile chemical. Chances, it seems to me, reasonable that you're going to volatilize some of that stuff up into the air, even if you're handling it as carefully as possible. Although, that's what they're trying to make to sell, so they're probably going to be somewhat motivated not to let it go up into the air. Here's my last thing. So once it comes out of the end, so basically you got a natural gas pipeline on one end of the building, and you got a pipe with methanol coming out of the other end of the building. You've used a whole bunch of electricity. You've generated a whole lot of hot water. And then you're going to store it. Right? There has to be storage because it's a continuous process. You might think, well, we'll just hook the pipe up to the ship and fill up the ship. Well, that's all good until the ship's not there or something happens. Right? You have to have some on-site storage. The document I saw from Northwest Innovation says they're planning on 2 weeks of production of full capacity, which is 30,000 metric tons of methanol stored on site. And I didn't really think about that until I started thinking about it. And it's like, how much is that? Turns out 30,000 metric tons of methanol is about 100 million gallons of methanol stored on the site. And then I thought, well, how much is that? It's really hard to kind of get your head around that. This is my office. This is the Center for Urban Waters. You are here, right? This is the Theophos Waterway. That's my office. Who else is here? Who else works in urban waters? Yeah, okay. This is New Star Petroleum Distribution Facility. They have 15 tanks. You can see of various sizes. Their capacity is about 15 million gallons. So the proposed storage on site is a big tank farm. It's a lot of storage. So something to think about. So when you think about, when you look at this site, what would it look like? You're going to see a lot of steam coming up, and you're going to see a big tank farm. And you're going to see a plant sitting next to all that. All right, shipping, I'm going to skip. We can talk about shipping later if you want. Final thought on this, and we're a little bit over time, but let me finish this with one last thought, because I think this is something I want you to go home with. I've heard that building this plant is a last gasp ploy by a dying fossil fuel industry, and like, why are we committing resources to build something in what is, we're trying to get out of the fossil fuel game, and we're locking ourselves into 50 years of more fossil fuel use. So I've heard that. I've heard people say this is like a bold response to climate change using super cool innovation. Like, this is the state-of-the-art way of making the methanol. If you make it this way, you prevent, or you basically crowd out of the marketplace dirtier ways of making the methanol. Right? So those are two different arguments, probably opposite sides of the argument. I want you to think about that as your homework assignment. I think the answer to that is kind of, it's kind of like a Rorschach plot. Right? Everyone looks at it and sees something slightly different. If you don't see two chickens kissing there, you're seriously in trouble. Come on back. Two chickens. All right, am I right? All right. All right, I'm going to wrap up. Here's why people who are excited about this as an environmental thing are excited about this as an environmental thing. Here's their argument, and I'll leave it for you to decide. There's this theory out there that methanol is the future. And the reason for that is conceivably you can make methanol from renewable energy sources. You can make it from wind, you can make it from solar, you can make it from geothermal. It's even possible to imagine that you can capture CO2 from the ambient air and turn it into methanol and turn it back into a fuel. So one of our big problems here is we have too much carbon dioxide in the air. It's possible, not in commercial scale yet, but it's possible to build a CO2 recovery system to pull the CO2 levels out of the air, right? I'll say more about that in a minute. So the concept here is, the reason that there's the argument in favor of doing methanol is that you build the infrastructure, you basically get the economy hooked on methanol instead of coal, right? It's kind of like methadone, right? You get off of one and go on to, don't write that down. Don't write that down. Oh God, there's the headline. But it's a transition, and the whole argument is it's a transition because there's hope on the horizon. Eventually we could make methanol not using fossil fuels, right? That's the argument. And it's a little more than an argument, it's actually being done. This is a little bit of an odd thing, but I'm going to leave you with this. This is a plant that's in operation in Reykjavik, Iceland. Anyone been to Reykjavik? Okay, so you go to Reykjavik, they always try to get you to go to the Blue Lagoon, the Blue something. There's a spa. Everyone takes everyone to a spa. It's a geothermal spa. Next to the geothermal spa is this plant. It's a renewable methanol plant. What it does is it takes carbon dioxide that's coming out of the vents, right? Hot vents, think Yellowstone, right? You get this hot gas coming out of the ground in Iceland, fairly high CO2 carbon dioxide concentration. They're recovering that carbon dioxide, turning it into methanol, and putting it into the cars in Iceland, which is kind of cool. Here's a picture of two guys from Iceland. They're actually in Denmark doing this, so they're using the methanol that they're recovering from this plant in Iceland, taking the CO2, preventing it from going into the air, turning it into a fuel that then can be used. The other thing that they've done is they've taken this methanol and built a methanol fuel cell. So you've probably heard of hydrogen fuel cells, right? Eventually we're all going to be on hydrogen fuel cells. Hydrogen is the fuel of the future and always will be, is what people like to say. There's lots of problems with hydrogen. Methanol fuel cells could actually work, and these are being used. They're putting methanol fuel cells in electric cars now, and it extends the range of the electric car by about 800 kilometers using this methanol that's recovered from the CO2 that otherwise would have gone into the atmosphere. So this is a little bit more than a pipe dream. This only works in Iceland because they have these vents that have really high CO2 concentrations, but eventually the idea is the technology will get good enough that we can pull the CO2 out of ambient air. And this is a lousy slide. Sorry about that, but just to show you that we live in a global economy. This just came out in last year. Headline, Reykjavik, Iceland. Chinese group Geely, who I'd never heard of. Anyone heard of Geely? Turns out Geely is the Chinese company that bought Volvo. So when you buy a Volvo, you're actually buying a car from a Swedish car from a Chinese company. They were so enamored with this methanol as a liquid fuel that they bought a significant share in this company that operates the world's first renewable methanol plant. So this, in many ways, a lot of people look at this and say, this is the direction we're heading for fuels. So I've gone way over, and I've probably given you more information than you care to know about methanol. We're going to transition into a Q&A period. Let's turn the lights up real quick. You can stand up. Don't go too far away because we're running real late on time. We're going to get the other panelists up here. Melissa Malott from CHB will entertain us with questions. So thanks for your attention. All right, let's go ahead and please take your seats, and we'll get started. The game plan is to have this go for about 30 minutes, and we're going to take as many questions as we can, and we'll be around to answer questions afterwards to the extent we can, but eventually it gets too late and you have to go home. So I'm going to turn it over to Melissa Malott. Melissa is the new Executive Director of Citizens for Healthy Bay, which is, as I think you all know, has been a long-standing champion of environmental issues in Puget Sound. So welcome to.
Thank you, Joel. Thank you so much, everyone, for being here to ask questions and learn about this, and thank you all for presenting. Citizens for Healthy Bay has been compiling questions over the last couple weeks on this, and up until yesterday we had only received 3 questions from the public, and then we received several dozen in the last 24 hours. So what I've done with questions is, and Ryan Cruz from my office have compiled some of the questions that were overlapping or duplicative, and we'll be dividing them between sessions. So for tonight, we're going to be focusing on questions that are more about the big picture of this, just to have it pertain to what we were presented with tonight. Questions related to water usage and water pollution and air pollution, to fracking, to other issues we'll save for another evening. So I'm going to start out with a question that we've gotten a couple times, and that is about potential conflicts of interest with Dr. Joel Baker's position and the Port of Tacoma. And so, Joel, I think you know the question, but I'll just let you answer it.
I've received it a few times this week. Yeah, so let me clarify who I am and what I do here. So I am a faculty member at the University of Washington. I'm paid by the University of Washington. My position was created through an endowment. And what an endowment means is that there was donations given, so the Port of Tacoma, the City of Tacoma, some private businesses, private citizens all contributed into a pot of money that sits in a bank. The interest on that pays my salary. The name of the endowment is the Port of Tacoma Endowed Chair in Environmental Science. So that's the position I hold. I'm also the science director at the Center for Urban Waters. Center for Urban Waters has an advisory board. As maybe many of you I hope know, Urban Waters is a partnership between the City of Tacoma and the university and the state of Washington. The building was built with a lot of community support and engagement. The advisory board was created many years ago, well before I came here, to frankly help raise the money and the political capital to build the Center for Urban Waters and to populate it with the first first activities within the building. The advisory board largely has gone dormant in the last couple of years. We have city council members on our advisory board. We have port commissioners on our advisory board. We have private citizens. We have academics, our chancellors on our advisory board, things of that nature. So there are members that have previously served on the Urban Waters Advisory Board who are now consulting for Northwest Innovations. I can tell you we also have advisory board members who are dead set against this project. So, and the advisory board had no role in designing this seminar series and didn't influence the work that I presented tonight.
And can I ask, just to just make it really clear, does the port influence your position, or do you influence the port? What is the nature of that relationship, just so people understand that?
Yeah, so when the endowment was made, when the port donated money to the University of Washington, as did the city, there was an agreement between the port and the city and the university that my position would help the city, would help the community in environmental issues. So it's a pretty broad brush. There's nothing specific about it. I do have coffee with this guy every once in a while just to touch base on issues with the port. We talk to the city all the time because we share a building with them, but there's no specific requirements of it was a gift to the university. It's not a contract or anything legally binding like that.
Great, thank you.
Sure.
The next question's a little bit easier. Will these presentations that you did be available online for review?
I'm sorry, I should have said that early. So all the presentations, I assume, are yours as well, will be available on our website, Tacoma.uw.edu/methanol. /methanol. That's why I don't do this live. So we will post the presentations from tonight. We're also posting the video that's being shot tonight. It will be produced by the UW-T videography group and will be available Monday morning. It's the same website you use to register. There's a click and it'll take you right to the video, and we'll set up the presentations as well. And that'll hold for the other presentations as well. So we'll get them out to the community as fast as we can.
Great. All right, so looking at the methanol plant, why is it going to be here in Tacoma? Why are they proposing it for here in Tacoma? And why are they proposing such a large plant?
Well, I'll talk about it from a port perspective, obviously. So one of the things that's unique about the particular property is that it is 90 acres in size, and the fact that it's immediately adjacent to the waterfront and there's a wharf there. So we know that production levels that the applicant has proposed and some of the production levels that Dr. Baker talked about today will require larger vessels to put the methanol or product into. And so it worked out really nice from that perspective in terms of being ready, in terms of the infrastructure that's already been constructed, and the fact that the site is a reclaimed brownfield ready to be put back into commercial use. So I think that's one of the things that the prospective developer was evaluating.
All right. And who is, I'm sorry, part of that question was also why the biggest? Like, why did they choose that quantity or that size of plant to propose?
Can I speculate wildly? I think that, and this is pure speculation on my part, my guess is that you proposed the largest thing you could imagine, and because it's easier to scale back than to scale up. As I understand it, it's actually four production lines that are 5,000 each, so the total is 20. You saw the list of all the other plants going on. This thing is 5 years out, 6 years out. Global economy changes, price of fuels change. I mean, is this ever going to operate at 20,000 tons per day? I think that's largely an economic question more than anything else.
Okay. The company that is proposing this is called Northwest Innovations Works. Who is the company? Who owns it? How is it funded?
Sure. So the company is let's see if I can get the string right. The company is a subsidiary of, is it Pan Pacific Energy, which is ultimately a subsidiary of the Chinese Academy of Sciences holding company. So it's a subsidiary of, it's eventually the Chinese Academy of Sciences.
Okay. And who is Chinese Academy of Sciences?
Well, that's a much harder question. I don't think it's analogous to our Academy of Sciences. I think it's a little more ingrained in I don't know. I don't even know if we have an analogy for it, a government corporation, you know?
Yeah, I mean, I again, speculating a bit, but my understanding is in the Chinese system, the Chinese Academy of Sciences, I know what our National Academy of Sciences is. It's a bunch of really smart scientists and engineers that get together and talk about science and engineering. That's not what this is. Mm-hmm. I think this is a government-owned sort of technology, sort of the technology arm of the Chinese government.
Mm-hmm. One of the questions we've heard a lot in the last couple of weeks is about is some concern that this is an LLC and therefore would have limited funds if there was some kind of catastrophe. Are there other companies in the port that are LLCs? You know, the concern is that this company wouldn't have the funding available or could just walk away if there was some kind of catastrophe. So I'm just going to leave that as kind of an open question.
Sure. I'll tackle that one. Tony, feel free to chime in. So yes, there are many other of our tenants at the Port of Tacoma are some form of an LLC, limited liability corporation. In fact, pursuant to the lease, I want to be really clear that there are some very significant insurance requirements associated with this prospective tenant. There's a requirement they maintain $50 million in general commercial liability and another $25 million in pollution liability. That's spelled out in the lease. In addition to that, they're required to provide 1 year's deposit in terms of what the full rent rate would be in that regard as well. So, and then back to the point about the cleanups, the port is on the hook for providing the financial assurance associated with the legacy contamination that would be required to be monitored and cleaned up going forward as well.
Mm-hmm. So with the cleanup that the port did on the site, I know you showed a chart of how much the port has put into it. What was that total cost, and how was that paid for?
Yeah, so I believe the number was just over $35 million currently right now. That was paid for primarily by the port, but the port did receive some grants associated with the actual cleanup. So primarily we received some Model Toxic Control Act grants. So the state, working with the state, going through their cleanup process, can grant you up to 50% of the remediation costs associated with that contamination. We didn't get the full 50%. We're still working on that. And then there was a small federal grant associated with the demolition because it was a RCRA compliant demolition.
Mm-hmm. And for port funding that didn't come from state funds, how does the port pay for things?
Yeah, that's fine. A couple different ways. So the port is if you think of the port, one way to think of the port is a large landlord. And so the port has property, and the port leases those properties, and they put that money back into productive use. And so ports, I called it a municipal corporation on my slide, run much like a private entity where they can take the proceeds from their lease revenues and invest that back into the port and the infrastructure and the people at the port. So that money was generated from other lease revenues. The port also can collect and does collect a property tax. And one of the things at a policy level that our commission said is that environmental initiatives, so things like cleanups and developing mitigation and habitat sites, we can use the money collected through the property tax levy to help fund those as well.
So would it be fair to say that, it sounds to me like you're saying, and I think these dots haven't been connected yet, but are you saying that, you know, the funding that you would get from the lease or from the rent would pay for the cleanup that's already happened?
Previous leases have been collected, the fundings associated with those. So no, the cleanup associated with what we've already done at Kaiser is not at all dependent on any potential or future revenue from the NWIW lease at all. No.
Okay.
Can I ask a follow-up question? The state money we referred to, is that coming from taxpayers, or is that a tax on something else?
Yeah, that's a thing. That is a tax. The Model Toxic Control Act taxes the petroleum that comes through the state, and it's a barrel tax put on through the process of manufacturing petroleum and converting it into gasoline. And as you can imagine right now, just as a side note, those revenues are way down with the cost of gasoline being down as well. But that is the funding source that the state uses.
All right. I want to talk a little bit about potential accidents or catastrophes, but before we talk about what the risks are, let's talk a little bit about who pays if there's an accident. You've talked a little bit about insurance. Are there other sources of funds if a catastrophe costs more than the insurance would cover?
So obviously, we would, as a port authority, we would hold our tenants responsible for that. They are, we believe that the insurance limits that we negotiated as part of the lease are sufficient. But absolutely, if there were any other, if those were exceeded, we would look towards the tenant to pay for that as well.
All right. All right. And then talking a little bit about potential catastrophes. Would this plant be explosive? We've seen there's maps going around social media about blast zones. How is that being analyzed?
Well, it is being, it will be analyzed in those technical reports I was talking about. One of them will be a life safety type report, health and life safety. We really can't comment on it thoroughly now because we just don't have the data. And we'll see what the report says. So this is the kind of information that'll be developed over the course of the spring and the summer.
If I could just add that there are some things that we know, and Dr. Baker talked about them. We know that methanol is flammable, and we know the level of its flammability. We also know that the system, the methanol will not be under pressure, which can lead to explosiveness. And so there are some things that we can currently kind of contemplate and talk about. The natural gas line that will feed the supply of the natural gas to the facility will be under pressure, so that will need to be evaluated as well. But we really believe it's more of a flammability issue as opposed to an explosiveness issue.
Mm-hmm. Okay. And Tony, you were talking about the report that's going to be done during the process of the EIS being drafted.
Right.
So that will be one of the technical
Well,
reports.
absolutely. And it'll define, that's exactly the kind of information it'll define. Again, the gas under pressure is explosive. Methanol is a flammable liquid. It's not, it's a flammable substance. It's not an explosive.
Mm-hmm.
So.
Okay. All right, switching gears a little bit. There's a report that came out a couple weeks ago about how the amount of plastic that's in the ocean by 2050 will be more than there's fish in the ocean. Let's talk about plastics because I understand that this plant would be making plastic or leading to the making of plastic, and I think there's community concerns about whether we want to participate in perpetuating this and what that means. What risk does plastic pose in the environment and oceans?
I think that's me. So let's see how to start on this. So the risk of plastic in the ocean is a serious concern. A lot of people, and you've probably seen the press, there's a lot of issues about plastic accumulating in the ocean. I, over the last couple of years, was one of the 2 U.S. representatives on the United Nations panel investigating the impacts of plastic in the world's oceans. We had people from all over the world, spent far too much time in meetings talking about this. The reports come out. There are places where plastic is a problem. Here's where I am with this, is that stupid use of plastic is stupid. Plastic bags are stupid. One-time, non-disposable plastic, or disposable plastic is a bad idea. What you do with the plastic is kind of critical to the conversation. So that somebody asked me, they heard like 97% of plastic produced in the world is only used once and is used for one day or something like that. And that's just factually incorrect. Most of the plastic that's used is tied up in things like plastic generally, tires and the thing you're standing on and that kind of stuff. So I am all in favor of getting rid of litter and plastic and marine debris and all that kind of stuff. We have to be on that. I don't think you can paint with a broad brush and say all plastics in the world are bad because of the serious marine pollution issue. That to me is a separate issue.
Mm-hmm. And where do you think that the analysis of, let me back up. This plant the people who are proposing this have looked at projections of the need for plastic over coming decades. So they've done like a market analysis and wanted to invest in it. Where does the community of Tacoma come into analyzing how it wants to participate in that?
Well, and just a point of clarification, it's really not necessarily the creation of plastic, it's the creation of the olefin that feeds into the feedstock for plastics and the other materials that Dr. Baker talked about. But the reality is that right now, this is the process. So we are going through a SEPA process, which is meant to be very public, very open, and this is a great way to have this debate. And the folks, the citizens of Tacoma and the greater surrounding area, they'll be able to provide those comments to the city, and the city will have to take that into their consideration as they go through and the environmental impact statement process.
And maybe if I can add on that, I mean, I think that's the key question here. I mean, that's the key question this community is wrestling with. You know, and like I said, you can look at this both ways. We don't want anything to do with this. This is someone else making something with our raw materials and making something that we're not that wild about, plastics, right? And they're probably profiting from it more than we're going to. So, you know, I get that argument. But the flip side is this, you know, if you're coming at it from the perspective of a chemical engineer and thinking about how we're going to make plastic anyhow, and you live in the world where there's going to be plastic in the future, then the issue is this like the state of the art? You know, are we leading the way by building the most efficient, most climate change friendly way of making methanol possible? If that's, and those are a bunch of ifs, but if all those ifs are true, then Tacoma could be a leader in fostering new technologies. That's that argument, and that's the fork in the road. I mean, like, we have to decide which way we're going to go with this.
Okay. During, I can't remember which presentation it was, there was a map of the port that showed it was zoned heavy industrial. We've had a lot of questions over the last couple of weeks about why this is being proposed here, and I would, you know, obviously it's because this is the place in the community that is zoned heavy industrial. Who made that decision to zone it heavy industrial? What's that process?
Yeah, a couple things. Not only is it zoned heavy industrial, it's also directly adjacent to the water, which is the way that the material could be transported, so really tying those two things together. But it all starts with the city's comprehensive plan development process. So there's a comprehensive plan. It's a requirement of the Growth Management Act. Cities of just about all sizes nowadays in the state of Washington are required to plan under a comprehensive plan. The comprehensive plan designates the area as manufacturing industrial center, heavy industrial, and then within that, the city designates specific zoning designations. I showed in my presentation the shoreline designation and then the upland designation, but that's all a result of the Growth Management Act, which was a legislation passed by in Olympia, and the city enacting on that legislation.
Mm-hmm. And then, so is the actual zoning decision made here in the community?
Yes, the city council ultimately approves the zoning designation. Just to be clear with the community, though, that is not being debated right now. The actual, the facility is what's being reviewed. We believe that the zoning allows this type of activity at this location.
Mm-hmm.
Can I maybe add a completely different flavor to this, but to the why Tacoma question? And as I've been thinking about this, and again, this is something I've kind of figured out on my own, and so this may not be right, but it seems to me that what's happening here is the following: is Tacoma has access to the water, they have electricity. You saw the aluminum smelter. You know, that was a big, I think of a big extension cord running into the site that is there, and that's hydropower. So if you looked at all those other plants that I showed, most of the other plants are going to fuel their process by burning either natural gas or coal. If they can build a plant here that runs on hydro, and the trend worldwide is to begin to tax carbon dioxide emissions from plants, mm-hmm. If they can make methanol in Tacoma that has a very low carbon dioxide emission, they're going to be able to undercut the market. That's just me making stuff up, but I think there's a third of that. So the why Tacoma is, if you can make methanol with hydroelectric power, you're going to be at a cost advantage relative to these other places. I don't have a degree in economics, but.
All right. One of the questions we got tonight is there a possibility to court other sustainable companies to build in the port in an effort to find an alternative to building the methanol plant? What has the port done to entice other types of businesses?
Yeah, that's a great question. So the port went through an extensive request for proposal process. So we essentially went out to the world, in fact, and said, we've got this 90-acre site, we've got this dock that's been constructed immediately adjacent to it. Send us what you might want to do. Send us some proposals that we can evaluate. So we went through that process fairly extensively over the last, I think that process kicked off in 2012 timeframe. It was a lengthy process, and there were a couple of different proposals that came back, a lot of them around petroleum. So there was a company that was considering building a tank farm, a petroleum tank farm there. There was also a discussion coal. There was a company or two that was looking at coal. Our commission said no to both coal and petroleum. And then there were some other commodities like pencil pitch and some other raw material commodities. Potash was another one. There was even a company that looked at doing another grain elevator at that point. But those companies decided that the economics did not work for them. So we continued to evaluate the methanol facility. But the point is that the port went through an extensive process and to solicit from the private sector what they might want to do there. And then this proposal came through.
Yeah, I think it's worth noting that pretty much everything that was proposed was a commodity of some type, and that the site is rail constrained as well, so it got a little tighter box than a lot of the other sites.
What do you mean rail constrained?
To get rail to the site, as in to get a train onto the property, you'd have to cross Taylor twice, and that creates all kinds of transportations issues out on that peninsula. So this looked particularly good because of the very, very low transportation impact.
Both from a rail and a road perspective.
Are there any subsidy programs, I'm just going off the top of my head here, but are there any subsidy programs to bring greener industries or industries that might be more in line with what the community would like to see there?
Yeah, so I think to Dr. Baker's point earlier, a greener industry, some would argue that this is in fact very green, and so we need to be mindful of that. I know that, for example, the Washington State Department of Commerce has some planning grants where you can take brownfields, and they'll provide some seed money for public and private partnerships to look at different types of opportunities. I don't know that it's solely based on being a sustainable green initiative, but I do know that the state offers that through the Department of Commerce. I'm not aware, though, of any others, what I'll use your word subsidy in terms of providing public money to look at a different type of use there.
Okay. So one of the slides said that there would be an increase in ships from, and there would be between 4 and 7 ships per month that would be added to ship methanol to China. Will that number of ships slow down shipping in the port? Will there be transportation backups because of that? What would the impact of that shipping be?
So 4 to 7 ships is not a big volume in terms of port operations by any stretch of the imagination. The Coast Guard will review this to see if there's any exclusion zone or anything, and it'll be very much, if there's a constraint on the waterway, which we've took a high cut evaluation of, we're not going to do. We don't want any facility in there that constrains our other shipping operations. But in the end, that would be a Coast Guard call.
Yeah, it's really important to note that we wouldn't want to put any type of use there that would impact our existing customers. Mm-hmm. And so, we did evaluate that as part of their proposal too.
Okay. And finally, has there been any study done so far on the impact that construction or other traffic related to this would have on traffic in and around the port and on 509 and on the trucks idling in and around the port.
So, no, the short answer to that is no, but look, to Tony's point, one of the things that's compelling about this use is the fact that outside of the construction window, because there will be significant deliveries and people moving back and forth to the site during the proposed construction phase, that during the operation phase, it's really limited in terms of transportation impacts. In fact, they're talking about just a couple truck deliveries per day to operate the site. But that will have to be further evaluated. We expect transportation to be a significant chapter in the EIS review, and that'll have to be discussed and evaluated as part of that process.
All right, thank you. I think we're at time. We're a little bit over time, but I appreciate everyone's efforts here, and I hope I did a good job of representing questions that people have, and I welcome feedback. You can find my email address at healthybay.org. Let me know how I can improve it if I do this again, and just let me know if I answered questions or got the questions out there. Thank you, everyone, so much.
Thank you.
Thank you, Melissa.